If the DHCP client requests a list through the request message that the DHCP server cannot fulfill, the DHCP server sends a DHCP NAC message to the client. This informs the client that the requested IP list will not be renewed. The client then begins the acquisition process again by broadcasting the DHCP discover message. When a Windows DHCP client boots in a new subnet, it broadcasts a DHCP request message to renew its list. The DHCP renewal request is broadcast on the subnet, so all of the DHCP servers that provide DHCP addresses will receive the request. The DHCP server responding on the new subnet is different from the server that provides the initial list. When the server receives the broadcast, it compares the address that the client is requesting with the scope configured on the server and the subnet. If it's not possible to satisfy the client request, the server issues a DHCP NAC messages, and the DHCP client then begins the list acquisition process again. If the client is unable to locate any DHCP server when rebooting, it issues an ARP broadcast for the default gateway that was previously obtained if one was provided. If the IP address of the gateway is successfully resolved, then the client assumes that it remains located on the same network from which it obtained its current list and continues to use the same list. Otherwise, if the IP address of the gateway is not resolved, the client assumes that the IP or the computer has been moved to another network or another subnet that has no DHCP services currently available, and it configures itself using either a PIPA or an alternate configuration. Once it's configured itself, then the DHCP client tries to relocate or locate a DHCP server every 5 minutes in an attempt to renew its list. IPv4 clients using DHCP retrieve all of the information you need for IP addressing from the DHCP server. This differs from the IPv6. By default, IPv6 clients use the DHCP to receive an IP address and configuration information from an IPv6 router on their network. This is referred as to a stateless mode. Implementing DHCP version 6 requires configuring your router to forward all of the auto configuration requests to an available DHCP version 6 server and disable only the stateless mode on your Windows Server 2008 DHCP server. Windows Server 2008 has introduced the Server Manager utility as a single point of reference for managing all of the components of the Windows operating system, as well as installing, managing, and uninstalling various server roles as an Active Directory domain services, DHCP, DNS, and others. Adding the DHCP server role is pretty much a wizard driven and allows you to configure the basic of DHCP settings, and at the same time that you install the role, you can make the configurations for your scope, reservations, exclusions, and other DHCP options. The DHCP server role requires the minimal server resources, so it can be run on a server that meets the minimum requirements for the Windows Server 2008. The DHCP server role starts the DHCP server service, install the files needed for the DHCP database, and initialize the DHCP console on the local system. The DHCP server database is a dynamic database, which is a data store that is updated as DHCP clients are assigned or as they release their TCP IP configuration parameters. Because the DHCP database is not a distributed database like the DNS server database, maintaining the DHCP server database is less complex. DNS is stored hierarchically across many different servers, with each server containing a part of the overall database. DHCP, by contrast, is contained in a few files on one server. The DHCP server database in the Windows Server 2008 family uses the join engine technology. That is a storage engine that was implemented for the first time in the Windows 2003. There is virtually no limit to the numbers of records a DHCP server stores. The size of the database is primarily dependent upon the number of the DHCP clients on the network. The size of the DHCP database is not directly proportional to the number of active clients list entries, because over time some DHCP clients entries becomes obsolete or deleted. This space is not immediately reclaimed and therefore some space remains unused. To recover the unused space, the DHCP database must be compacted. This means that the database must be optimized to reclaim unused space that has been left by adding and removing records. Dynamic database compaction occurs on the DHCP servers as an automatic background process during idle time or after a database is updated. The DHCP server service is installed with the DHCP server role. This service runs the processes that DHCP servers uses. If the service is not running, DHCP clients cannot receive IP addresses and configuration information from the DHCP server. After the DHCP server role is installed, the DHCP server console is available in both the server manager and under the administration tools. These tools are stored in the administrative tools folder on the Windows Server 2008. The server console is a graphical interface tool for managing the DHCP on Windows Server 2008, and it provides tools for configuration for both IPv6 and IPv4 DHCP implementation. In implementation of DHCP prior to Windows 2000, any user could create a DHCP server on the network, an action that could lead to conflicts in IP address assignments. For example, if a client obtains a list from an incorrectly configured DHCP server, the client might receive an invalid IP address, which prevents it from communicating on the network. This can prevent users from logging on. In Windows Server 2000 and later, an unauthorized DHCP server, also referred as a rogue DHCP server, is simply a DHCP server that has not been explicitly listed in the Active Directory domain services as an authorized server. You must first authorize the DHCP server in Active Directory before the server can issue lists to the DHCP clients. At the time of initialization, the DHCP server contacts Active Directory to determine whether it is on the list of the servers that are currently authorized to operate on the network. One of the following actions then occurs. First, if the DHCP server is authorized, the DHCP server starts. And second, if the DHCP server is not authorized, the DHCP server service logs an error in the system event log, does not start, and of course would not respond to client request. Active Directory must be present to authorize DHCP server and block unauthorized servers. If you install a DHCP server on a network without Active Directory, no authorization will take place. If you later add Active Directory, the DHCP server will sense the presence of Active Directory. However, if it has not been authorized, the server will shut itself down. DHCP servers are not authorized by default. They must be authorized manually. When a DHCP server that is not a member server of the domain, such as a member of a workgroup for example, initializes for the first time, the following steps happen. First, the server broadcasts the DHCP inform message on the network. Second, any other server that receives this message responds with a DHCP ACK message and provides the name of the directory domain it is part of. Third, if a workgroup DHCP server detects a member DHCP server on a domain of the network, the workgroup DHCP server assumes itself to be unauthorized on that network and shuts itself down. And finally, if the workgroup DHCP server detects the presence of another workgroup server, it ignores it. This means multiple workgroup servers can be active at the same time as long as there are no active directory services. Even when a workgroup server initializes and becomes authorized because there is no other domain server or workgroup server is on the network, it continues to broadcast the DHCP inform every 5 minutes. If an authorized domain member DHCP server initializes later, the workgroup server becomes unauthorized and stops receiving client requests.